Hi guys, welcome to our first recorded lesson. As you can see, I'm not here today, or I'm not there today. But we're gonna get through these notes pretty quickly and then you'll get some practice just a little bit, and then I'll be back tomorrow. So to get started, I want us to look at the calendar. Notice how our first homework that comes up is going to be on well, what's happening here? Okay. Is going to be due next Monday. We'll start it on Wednesday and it'll be due next Monday, the 15th. Notice how that day we also have a quiz about angle relationships and algebra. Looks like when we start that, when we start getting deeper into angle relationships and algebra is going to be on Friday. That day we also start our second homework, which is going to be due on Wednesday, the 17th. Okay. And that same day, we'll start our third homework and so on. We have the two quizzes this unit, and then instead of a test, we're going to be working on parallel city. I say instead of a test, we probably will still have the DEUA at least, but this project will be a test grade. Okay, let's get right into it. Oh, let me find my uncompleted notes for y'all. Where are we at? Let's do this one. Okay, here we go. All right, skew lines. So starting with parallel lines, these are coplanar, coplanar lines that never intersect. Now, what is coplanar? Coplanar means, we said co means together, planar means on the plane, so coplanar means together on a plane. So these are lines that are together on a plane. All right. So parallel lines are coplanar lines that never intersect. And parallel lines, with these lines, we use arrows to indicate that the lines are parallel. Now, an example of these arrows are over here to the right. Notice how we have these two little matching arrows on these two parallel lines. Those tiny little arrows tell us that these two lines are parallel. So what we're going to say here for the symbolic notation, according to the picture to the right, which you can't see at the moment, but it's there, we're saying that line AB is parallel to line CD. Now, as a reminder, the symbol for parallel is that double line, like this. It kind of looks like an 11, but these lines are bigger than a number 1 that you would write. So if I were to write like 1, it would be smaller. That's besides the point, though. Okay, now we talked about parallel lines. Let's talk about parallel planes. Parallel planes are planes that never cross. The symbolic notation, let's look at the picture to the right. We have two planes. They are not touching. Yes, it has this dotted line here. You might be wondering about that. That dotted line is just to show you that this plane K on the bottom, it's not connected to the plane above it. That line right here continues even though it is beneath the other plane. Even though it is hidden, it still continues there. So that's what that dotted line means. That the shape continues even where we can't see it. So symbolic notation of these parallel planes, we could say plane J is parallel to plane K. And if I'm moving too fast for you, you can definitely pause the video or slow down the video on YouTube. You can slow down the speed. All right. Next, we have skew lines. And this is a new word for us, but skew, that's how you say it, skew. And skew lines are non-coplanar. So what does that mean? Non-coplanar is referring to lines that are not together on the plane. So not together on a plane means coplanar. Skew lines are non-coplanar lines that never cross. Excuse me. All right, so let's talk about how to describe what skew lines are. We can say that skew lines are not on the same plane. Or we could say they're on different planes. Let's do that. On different, I'm just going to say diff planes. And never cross. And, oh my goodness. And not parallel. Okay, so skew lines are lines that are on different planes, never cross, and are definitely not parallel. So let's look at our example to the right. Some examples of skew lines could be, let's start with TU. TU. What line would be not on the same plane, not cross TU, and not parallel to TU? We could say VR. What about SP? We could say UQ. UQ, oh, I forgot to write SP. SP. Okay, and the last pair of segments that we could say, we can say more. There are tons of examples on here, but we're just looking for 3 examples. Starting with WT, we could say SR. All right, moving on. Now, example 1 and 2, I will do, and then I want you to do the other 2. It says name all segments parallel to segment AE. Let's highlight segment AE so we can see parallel is what we're looking for. So we got FB, GC, and HD. So we can say HD, GC, FB, yeah, FB, GC, HD. Okay. Give 2 examples of parallel planes from this picture. So we're looking for parallel planes. So we could say this plane and this plane are parallel. So how do we name planes? We use 3 letters. Plane F, G, C, and plane E, H, D. Another pair of parallel planes, we could say this top one and the bottom one. And again, we use three letters, plane H, E, F, and plane A, B, C. It doesn't matter the order of the letters when you use them, um, as long as you use three. Oh, sorry, guys. Name all segments skew to GH. Let's see, GH is right here. So skew to GH, we could say FB or EA. We could say BC or AD. Let's go ahead and name those. Sorry, my handwriting's getting worse the more tired I get. H, G, B, C, AE. All right, example two. Name all segments parallel to JK. Where's JK? Right here. So parallel would be the other side, which is just OP. Name all segments parallel to NS. NS. Perfect. So parallel lines could be MR, LQ, KP, and JO. Name a plane parallel to plane JKO. So it's that face right there. So it's going to be the other face. And we use three letters. So we're going to say plane SRQ. Name four segments skew to RQ. Oh, that's an O. Haha. RQ. Four segments skew to RQ. Okay. So we got KP, JQ. Oh, there I am thinking that O is a Q again. JO, this one. NS and MR. NS, MR, and these should all have lines on top. And then the last one is LQ. Okay. Oh, it says four, so I guess I don't have to name the last one. Whoops. Okay, four. Now if you named LQ, totally fine. Use the diagram below to answer the following questions. All right, I want you to answer these questions. I'll show you my answers at the end. Actually, I will not show you my answers. I want you guys to answer these on your own and then talk to your neighbor about them and figure out who's correct. Okay? So let's say these are to do on your own. Gosh. You do those. All right, flipping over to the back side. It says Skew Lines Mini Notes. So here on this page, you're also going to do on your own. I want you to draw the points. So I guess not draw the points, but plot the points. That's the word I'm looking for. Plot points. Draw the lines to create the segments. draw lines, and then calculate the slope. And tell me what relationships are those two segments having? Like for number 1, we got A, -3, 1. B, 3, -3. And C, 3, 6, 7, 3. All right, the question is asking for AB, the relationship between AB, so we need a line between A and B. Oops, not that one. AB and BC. What is the relationship between these two segments? So let's find slope using our slope formula form. Okay, so we got 3 plus 3 -3. Oh, I see what I'm doing wrong. Haha, I'm so tired. I'm sorry, guys. We got -3 minus 1 over 3 plus 3, which is, what? Am I crazy? -3, 1, 3, -3, 7, 3. Okay. So the segment AB slope is -3 plus 1. Okay, girl, we gotta start this over. So sorry, guys. -3 minus 1 over 3 plus 3. -3 minus 1 is -4. 3 plus 3 is 6. So we end up getting -2/3. Bam. Okay, let's calculate the other one. It says BC. So between B and C, what is our relationship? 3 plus 3, 7 minus 3. 4, duh. Okay. 3 over 2. Look at these two slopes. What kind of slopes are these? They're perp. All right. So go ahead and continue this side as well. That's right. Do these. All right. And again, converse with your neighbor. Make sure you plot your points right. Okay, that's going to conclude our notes for the day. 17 minutes, gosh. So go ahead and answer all the questions from what I showed you. Let's take a look at the homework. Did we start the homework while I'm gone today? It said we're not going to start it until Wednesday, but let's see. Oh, just kidding. I have to do the vocabulary. All right, just a little bit longer. Continuing on through the vocabulary, we just got 2 pages of drawing pictures. Let's do it. Ooh. Hopefully I don't fall asleep on you guys. Okay, it is way too late for me to be up right now. Intersection. An angle is the intersection of 2 rays at an endpoint. So a visual for our angle is an endpoint there we go. That doesn't look that great, but there's supposed to be a point right there. Okay, so we have A, B, C. And to verbalize this or to describe this by hand, we can say angle ABC, or we can call it angle B from that center vertices. Okay, vertex. Next, we have the vertex, which is the common endpoint of an angle, which is just this point right there. So let's copy the same picture down. A, B, C, where B is the vertex. A right angle, we all know this one. Right angle has exactly 90 degrees, and that is signified from the little square inside. If it does not have that little square, we cannot assume it's 90. Acute angle. Cute, think cute like babies. Babies are small. Acute angles are really small too. AKA, they are less than 90. That's a degree. There we go. All right, obtuse angle, an angle measuring more than 90. So this is a very big angle here. Like this. We can put some points here like we did already. A, B, C. And we could say this angle is 140 degrees, which is way bigger than 90. Now, a straight angle is just the way it sounds. It's a straight line. There we go. We can call this XYZ. And it is a straight angle because this angle is straight. How do we know it's straight? It tells us it's 180 degrees. 180 is half of a full circle, right? So 180 is going to be right through the middle. Flat line. Next we have congruent angles, which is signified by the equal sign and the squiggly on top. These are two angles of the same measure. So let's go ahead and draw two angles and call them 30 degrees. Okay. And usually when there's a measurement, there's like a curve in the angle like that. So there you go. If you have questions or are confused, please pause the video. Adjacent angles. Adjacent angles are angles that share a common side and vertex. So adjacent angles are really just an angle that's been split into two. It doesn't have to be two perfect halves because it's not a midpoint, or in this case a bisector, which we'll talk about in a moment. So these two separate angles, well, they're together, but they're two separate angles. These are two separate angles. All right, it says if angle, this is the angle addition postulate, which we've already done the segment addition postulate, but now we're doing angles. So basically we could say that put two angles together and they equal the whole. Part plus part equals whole. Let's say, I don't know, part, what am I saying? Part plus part equals whole. Okay, don't know what I wrote there. All right, so okay, let's draw kind of an obtuse angle. We can say ABC. And we could put like a random angle right here. We could call this angle 1 and angle 2. These together are angle addition postulate. Angle bisector. A line or ray that divides an angle into two equal parts in half. So here we go. But we can mark it like this to show that the tick marks tell us that it is divided in half. Okay. Moving on, vertical angles, we are almost done, thank goodness. Vertical angles are two angles directly across from each other on intersecting lines. These are always congruent. This is vertical angles, so we got 1, 2, 3, 4. Now we could say, to describe this, we could say the measure of angle 1 equals the measure of angle 3. And same thing for the across angles. The measure of angle 2 equals, oops, I think I wrote that backwards, but the measure of angle 4. Okay, next one, complementary angles. Complementary angles add up to 90. So we could draw two angles that are not 45 degree each, and they add up to 90. $60, and then over here we could have like 130 degrees. These two angles together create that right, oh, not 130, just 30. There we go. All right, supplementary angles. Sorry, these two angles together create a right angle because 30 and 60 is 90. So they're complementary. Supplementary means two angles with a sum of 180. Now they don't have to be adjacent. So let's say your girl is struggling. Here we have 115, and here we have 65. All right, last one. Yay, linear pair. Adjacent, supplementary angles, aka share a side and have a sum of 180. All right, so we got boom, boom, 100 degrees. All right, go ahead and get those questions done from the last 1A and 1B, and then I'll take a look at them on Monday. All right, well, thanks for watching my video, and see you tomorrow.